I am Guru Prasad Das. I have completed my master degree in physics and now I am currently doing the B.Ed. So I will discuss about quantization of electric charge. Okay. So you all know about the statement the charge is quantized. But what is the meaning of quantization? Okay. So first of all take an example. Suppose take two charged body. Suppose this is one body, this is another body. Okay, so this is suppose A body, this is B body. Let the charge of body A is Q1 and the charge of body B is Q2. Okay, and Q1 greater than Q2. Okay, so according to the quantization, if I will rub these two bodies, then only integral number of electrons will be transferred from body A to body B. Okay, if I will say 2/3 number of electrons will be transferred, then that concept is totally wrong, because the fractional number of electrons cannot be transferred from one body to another body during the rubbing. Only the integral number of electrons means one number of electrons, it may be 5 number of electrons, it may be 6 number of electrons will be transferred from body A to body B. Okay, so the formula is Q is equal to N into E, where Q is the total amount of charge that transfer from one body to another body, then N is the number of electrons. So this is the very important point. The number of electrons should be integral, means 1, 2, 3, 4, 5, 6, that things. Okay, the fractional number of electrons cannot be transferred. E is the charge of 1 electrons. You know the value 1.6 into 10 to the power minus 19 coulomb. Okay, so the definition is the quantization of a physical quantity, not only electric charge but also energy also be quantized, the angular momentum also be quantized. So the quantization of electric charge means that it cannot vary continuously, means it cannot vary continuously. Okay, so it cannot vary continuously, it always changes discontinuously to take any one of only a discrete set of value. Okay, so that is the main point of the quantization. Now I will solve a problem about the quantization of electric charge. Okay, the formula is, I have already said, Q is equal to N into E. So let's see the problem. It is given that if a body gives out 10 to the power 9 electrons every second, so in each second the body gives 10 to the power 9 electrons, then how much time is required to get a total charge of 1 coulomb from it? So how many time required to get the total charge of 1 coulomb from it? So the Q is equal to 1 coulomb. So in 1 coulomb of a charge, how many electrons present? So you know the formula, Q is equal to N into E. So N is equal to Q by E. Okay, so Q is equal to 1 coulomb divided by E is equal to 1.6 into 10 to the power minus 19. So after solving this, you can get the value 6.25 into 10 to the power 18. So in the 1 coulomb of a charge, there are 6.25 into 10 to the power 18 electrons present. Okay, so but in the question it is given that in each second it can provide 10 to the power 9 electrons. That means to extract 10 to the power 9 electrons, it required 1 second. So one electron can be extracted 1 by 10 to the power 9 second. Then this number of electrons, so 6.25 into 10 to the power 18 number of electrons can be extracted is equal to, just multiply it, 6.25 into 10 to the power 18 divided by 10 to the power 9 second, so equal to, this equal to 6.25 into 10 to the power 9 second. So 6.25 into 10 to the power 9 second time is required to get a total charge of 1 coulomb from it. So this is the answer. So I hope you definitely understand this concept about the quantization of electric charge. Again I am saying the quantization of electric charge means only the integral number of electrons will be transferred during the rubbing. Integral number of electrons means n is equal to 1, 2, 3, 4, 5, 6, etc., etc. Okay, so if I will say 2 by 4 number of electrons, 2 by 3 number, if I will say 2 by 3 number of electrons, 5 by 4 number of electrons will be transferred, the fractional number of electrons cannot be transferred during the rubbing. Only the integral number of electrons will be transferred during the rubbing. Okay, so I hope you must understand this concept. Thank you very much.